Good afternoon, everyone. It's Smitty here. I'm pretty sure I start streaming, and I'm going to be working on something today. On my last session where I was sitting here working on something, I started working on a clock using WS2812s, making a 7-segment display out of them to use as like a bedside clock, with something that you can change the color and the brightness on pretty easily. And then control with an ESP8266, because that seems to be what I've been doing these days. That has Wi-Fi, can do NTP, the clock will always be accurate, that kind of fun stuff. I'm also building into it a 3 amp 5-volt power supply and several USB ports, charging ports, so that I can use it to charge all of my various devices, like my AirPods and my Apple Watch and my iPhone. I wasn't intending to pull all those out, but luckily they're all within my reach. So I can charge all 3 of those things on my bedstand at night using short, convenient cables and not having to run a bunch of cables from somewhere else. All I have to do is run a 12-volt up from the wall to my clock, and then get the power for the charging those devices. Last time, I laid out all the schematic. A lot of 2812s, a lot of capacitors, some USB ports, and the power module and various things. And started laying out the components on the board. I only really got to the 7-segment display section for the WS2812, but I didn't do any traces. I didn't lay out any of the other components. So I'm just going to pick up where I left off on that. Let's see here. There we go. And also, today I'm going to be listening to the wonderful Shadowrun Hong Kong soundtrack by John Everest. I believe he is John Everest on Twitter. This is an amazing soundtrack. If you don't have this, it's one of my favorite background, kind of low, down-tempo background music while working kind of albums. So highly recommended. I'll stick a link to it in the show notes here. Hopefully it's not too loud, that you'll still be able to hear me talking, but this will be good for getting me kind of amped up and ready to go, although it's down tempo, so it's maybe not all that amped. Hey Joel, nice to see you. Nice idea. What was my nice idea? The delay here means I don't know what you're responding to a lot of the times. Okay. And I see 2 people in the chat room now. If you are in the chat room and haven't said hi, please do. Just, give me a quick, hey, I'm watching, or I'm not watching, or you goofball, you put this in the wrong place, or whatever, right? I love hearing from people in the chat. Oh, so schematic. So the power in, just going to be a standard barrel plug. And this connector here is actually, because I just didn't make a schematic outline for it, but it's one of those like 3 amp switching power supply modules from eBay for $2 or $3. And so it takes 12-volt in, or whatever you give it, as long as it has enough power, and puts out 5 volts. So that's all that is, and then everything else runs off of 5 volts. And we got a couple of bypass caps, filter caps right at the USB ports. We got 3 USB ports there. I'm not hooking anything up to the D plus or D minus line, so it's only going to be providing half an amp, or rather, the devices that are connecting to it are going to assume that it's a low power device and only pull up to a half an amp. I may change that in a future design. Let's see here. This is the ESP8266, and just wired it up. Another filter cap for the ESP. Got a reset button. I got the program button. And then we have a serial module header here for programming the ESP8266. A bunch of bypass caps for all the WS2812s, because we have a lot of them. And then this page includes all the 2812s. It's just a long string. Just a long string of WS2812s, but they're in pairs, because every 2 LEDs are going to make up a segment of a 7-segment display. And so, like, this is the A, B, C, D, E, F, and G, and here's your 7-segment display. So the line's going to go this way, around, hit C, come back around to D, E, F, and G, and then go out to the next A, B, and so on and so forth, because it's a big string of LEDs, with the serial out of one going to the serial in of the other. So that's the schematic design. Let's see here. Nope, not that one. That one. Here we go. So these are the parts that I have laid out so far. These are the 2812s. What I need to do is I need to get these capacitors underneath the 2812s. I'm debating whether I want to have one bypass cap for every WS2812. In theory, that's the right thing to do, but that's an awful lot of capacitors. I'm thinking about doing one cap per pair, which will just kind of, I don't know. I don't know how critical they are. I don't think they're really all that critical. So I'm thinking about just doing one per pair. Let's grab those, move them over here so I can get easier access to them. Oh, I also want to flip all of these. Can I flip them as a group? Because I want these to be on the bottom side of the board. Hey, look at that. I can. Okay. Actually, you know what? I'm going to put these under the VCC side because I'm going to put a ground plane on the back side and a VCC plane on the front side. And that way I only have to do a single via to connect the VCC pads. Footprinted, no, that one there. Because those 5 plus 5 volts are right on top of each other. That ground is connected to that ground, but it's brain. But it's going to be a ground plane, so it'll just automatically fill those together. So, okay, that's a good way of doing that. All right, so I lied. Apparently, I am going to put down each and every one of these. Dang it. I always try to grab them and they're not. It wants to do something. Nice idea is the clock project in general. If someone was going to fork this project to have a Qualcomm quick charge ports, would it be more expensive, more difficult to implement? No. Well, only slightly. So actually, what I'm likely to do, I just need to do some research to figure out how to do it before I plug this in. The way you tell it how quick to charge from is by you put a resistor divider on the data lines. And so the device looks for certain voltages. The device looks for certain voltages to appear on the data lines, and when it sees those certain voltages, there are standards for how much current the power supply is capable of supplying at that point. And so really all you need to do to set it for a certain amount of power is to put some voltage dividers between the 5 volt and the ground, and it will instruct the device how much power to pull from it. So my question, the one thing I don't know is exactly what the values are for each of the devices. So what I'm likely to do is just put the outlines on the board and then leave it up to the implementer to decide which resistor values go into each position to put those voltages in the right place so you can set it up for your particular phone. Does that make sense? There we go. Just putting more in there. Doo-doo-doo. Oh, why did I put these sideways? I don't know why. Debating the logic of having these rotate around like this. I think it looks better from a layout or from a visual perspective, but it's going to make assembly kind of a raging pain in the butt. Although I guess I did manage to only do 2 orientations, so that's good. Hey, Joel, or anyone who's listening, can you confirm for me that you can hear the music and that it's not too loud? Is the volume good on the music? Beginning to wonder whether I have enough capacitors. QC from Qualcomm might be a little difficult to apprehend. It's a certain standard. Okay. Well, so to answer your question, I don't know anything about the Qualcomm standard specifically. So to the degree that the Qualcomm standard is different than the Apple standard and various Google standards, then I really have no idea. I have not looked into Qualcomm at all. I'm an Apple user, or rather, an iOS user. And so all of my research has been centered around charging iOS devices. Because I prefer the business model of gouging your customers on hardware versus selling your users' information to your customers. That's just a personal preference thing. Whoops. Dang it. You can hear my voice mostly. Does that mean that the music's probably a little bit too loud? Should I turn down the music? Oop, 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 oop. This is a lot of capacitors. I normally solder my stuff by hand. I might do this one with a, oh, come on. With a oven. Oh, got them all. Okay, so those must be for other things. Oh, you can barely hear the music. Okay. Well, that's probably good. Y'all are here to watch me, not listen to the music. If you want to listen to the music, I recommend you go get it somewhere else. Because you don't have some jackass talking about circuit layouts above it, on top of the music. Okay. Let's lay down a whole bunch of vias. Yoink. And what is it? Plus? Oop, oop, nope. So what I'm doing here is I'm literally just dropping a via between a pad on the top and a pad on the bottom, because the power is going to be on a plane. What are you doing? On the top. So all I need to do is get it through the board to the surface mount pad on the bottom of the board. Wait. Oop, nope, there's more up there. Mm-hmm. Joel Hudson says, "Happy Sunday, Smitty." From another Joel. Hey, another Joel. How you doing? We got lots. We have a redundant array of inexpensive Joes, although I don't know how much you guys charge, so maybe not so much on the inexpensive part, but we have a redundant array of Joels. I almost called you Joe. And that would be wrong. Okay. What does that do? Let's move some of the stuff closer. So I've got less spread out all over the board. I use that joke all the time. As long as you don't call me late for dinner, I'm good. Yeah, I can respect that. Okay. All right. So now I've got things on the board. I got to figure out where I want things to go. So we are looking at the front face of the board. I'm going to want these probably on... we'll keep them on the front. I think I'm okay with that. Do I want double stacked? You know, I think I do want those on the back. Okay. All right. Let's put these. Actually, we do want these on top. Okay. Got 2 more. Why do I have 3 more? Did I miss a capacitor somewhere? Whoop, dang it. I got 2 caps there. 2 caps on each of those. I bet you I just have 1 too many in here. Okay. That's fine. Oh, bum. All right. Well, let's put the Wi-Fi over on this side. Where am I going to have space for those holes? Or do I want to try and make the surface mount on the back? Actually, you know what I'm kind of thinking about doing is making this 2 separate boards, because then I can just have a small connector between the 7-segment display board and the other board that's got all the stuff on it, put standoffs between them, and then the 7-segment display board will be... Yeah, I'm kind of liking that. So what I'm thinking is... So what I'm thinking is making the 7-segment display its own board that doesn't have any other stuff on it, except for a connector that connects it to another board behind it, and that other board behind it can be smaller, or maybe the same size, I don't know. Anyway, and that other board has all of the components on it. What that does is that allows all the other components to be through hole without having to worry about where they end up poking holes in like these LEDs, right? Because so the problem I'm running into is that this module's got to go somewhere, but unless I have it, sticking way off the board, I guess, dang it. Even if I do something like that, what you end up with are these, these holes. The backside, the solder side of those headers are going to be showing through on the display, and I'm not sure I like that. I kind of want to keep this display as clean as I can, and the same with all of these connectors over here. And it just kind of makes the board bigger and more unruly. It's going to be more expensive if I make a second board, because, well, either that or I just make the second board more compact and it's smaller square inchage. But what it will do is it'll allow me to keep the display board nice and clean, and then the second board has all of the through-hole stuff, but it's behind, so I don't care. I'm kind of liking that idea. Okay. Boom, boom, boom. Yeah, because that one's going to leave some big, gnarly, ugly holes, too. Yeah. All right. All right, so let's make a board out of this then. Edge cuts. Line, okay. Actually, before I do that, I'm going to go drop some mounting holes. M3. What? Oh. That's not what I meant, but okay. So that does not have a ground plane. Do I want to have a ground plane on this? No, a pad. I kind of don't. I want it to be nice and clean. What I don't know is whether these signal keep-outs. All right, we'll find out. So the position on these is just arbitrary to make it small outline, which I may regret later or I may change. I think I want to do another set right in the middle. Maybe right there. I think where these holes go is going to depend largely on how big the board for all of this has to be. Whoa. Wait a sec. Ah, dagnabbit. These are off. So, I don't know if you noticed, but these LEDs were off from the grid from the other two. So these two digits were off on the grid from these two digits. So I just lined those up. Okay. All right, I think that'll be good. And then as long as I can keep everything on my power board within that space, I can just put a second board on the back of it. Okay. So let's make that outline. Actually, shoot. Oh, is this literally just going to be exposed? All right, so what I'm thinking about now is how am I going to mount this? Because if I mount those, if those mounting holes are right there, and I want to have a, so if the circuit board is here and I want to have like a frame, an outline in front of it, that means that I have to have an opening here, but a screw hole there. I guess I could do that. It's just going to have to be, I'll probably have to laser cut or maybe 3D print a front panel, assuming I want a front panel. If I don't want a front panel and I just want the thing to be exposed, that would actually kind of look neat too. Or I can just use a clear acrylic, at which point all of that would work just fine. Okay, you know what? I think I am going to do that. I'm going to err on the side of a small board. Okay, doke. Edge cuts. Let's see here. Gonna go out an arbitrary amount from the edge of the mount hole. I can adjust this later as necessary. Knock it off. So where is that? That's 1.05 by 3.2. .25, so that's 5 1/4 inches wide by 3.2 to 5.05. Oh, math. Just shy of 2 inches. So it's like 5 1/4 by 1 7/8. Yeah, that's a good size. I think it's a good size for a bedside clock, don't you? All right, so I'm going to need a way. I need to find out where the beginning of this line is. Oh, dadgummit. Which one is in? Oh, shoot. All right, well, let's do some research. WS2812B schematic. What is... What is the pinout? So... Power supply. VDD is the +5. VSS ground is next to in. Okay. So if there's ground, there's the in. Oh, that. Okay, there we go. There's our input right there. So it goes around this way. Okay. That's good. And that should mean that that way. Where? Oh, it's that red pad in there. So that those rat's nests right there are for the ground on the capacitor. Yeah. Net. Okay, so LED one, pad 1. Yeah. I think that's saying that that pad isn't actually connected to anything. Yeah, there's no rat's nest leaving that pad, so that is the output. Okay. The output of the string. Okay. All right, so let's go put some connectors in here. I want to power, ground, and data. Is that all I need? Yeah, it's kind of the whole point of WS2812s. The question is whether I want any, like do I want to beef up the power and ground lines, or do I just think a single pin will be enough? Now let's go with single pin. I just tied D2 directly to it. All right, edit, D2 LED, okay. That abrupt ending to that song has always been a little weird. Okay. Oh, save that. We're going to have to pick some components. Well, we're going to have to annotate first because I added new components. Oh, let me set some values on this. LED board. Value. Controller board. Okay. Save that. We've annotated it. Let's go put some components on these. Really? There we go. Pin headers, I think is where it's called. Yep. Pin headers, angled. Nope. do a viewer. Do I want straight through hole pin headers? Surface mount. There we go. Oh, shoot. The surface mounts are only 2x? Am I willing to allow that one? Yeah, you know what? I am. Okay. So, nope. Get out of here. Okay. Thought process. I wanted those. Again, I'm trying to keep the display board entirely surface mount. I don't want any, like pin headers sticking out the backside. And that's hard to do with connectors. They do make surface mount connectors. The pinhead, the 0.1 inch DuPont pins. They do make them, but they are they only come in 2 in a row. You can't. They don't make one that's just a single row. Why did I set a timer? I don't know what my timer was set for. Oh, I do know what it was set for. I'm going to ignore it for now. They do make them in single rows, but apparently KiCad doesn't have the outline for it. So we are going to just replace this with a 2x, and I'm just going to double it up. So and I'm going to drop some new connectors in here. Con 02x03, like that, and we're just going to go ploink. And I'm going to, well, first off, copy that down here, and left facing, yoink. Okay. Copy. Edit, left, go. All right. Let's drop the wires. No, okay, not quite drop the base, but whatever. All right, so we're just going to a 2-row connector so that we can easily do the surface mounts, and it's just going to be the same signal on both sides. That's fine. Although I guess I don't care too much about surface mount on the controller board. That needs to get re-annotated because I deleted the other ones. And then we'll go back over here. Oops, forgot to rename them. That's okay. Pin headers. Ah, dang it. Pin 1. They do have the SMD. The other ones are more sturdy, and that I was considering doing it anyway for current carrying capacity. So we'll just go ahead and stick with the 2x3, and I want that one. Yeah, we'll stick with that. Okay. Now I need to save that, and I need to generate a netlist. Generate. Yep. And then come over here and read a netlist. Close. Why did those wires move? There were wires that moved that I didn't expect to move. Okay. That's the one that goes by there, and that's the one that goes up here. So it gets tied to that pin. where do I want it? Because the backboard's going to have a bunch of those USB connectors poking out. So I don't want it right next to that. Well, first off, we're going to have to flip it. And we'll do that for now. Okay. I kind of want the USB port sticking out the side, because if you put it out the top, then it means that nothing can plug into it, or nothing can lay on top of it. I don't want them out the bottom. Let me see if I've got a double stacked. So the problem that I'm running into is that these USB connectors are too wide to have 3 of them. I need at least 3 ports, and it's wider than this board. If I got the double stacked USB connectors, then I could fit 4 ports right there. And if I moved these out and just made this board a little taller, I could even recess them so that they're flush with the edge of the board. And I don't already have those connectors. I've already got single ports, though. Shoot. Wait a minute. Wait. Hold on. Have an idea. Let's see if they support it. They also make vertical USB connectors. Connect. Aha! Vertical. That is what I think I want. I will have to go buy some, but that's okay, because I can squish 3 of those side by side pretty easily. I am pretty sure that is what I want. Okay. So USB-A, and vertical. Okay. Save. Save that one, generate a netlist. I don't need to re-annotate because all I did was change the connector. It still has its annotation. But I do need to delete that. Because it won't load the new one if it already has it on there. So if I read the current netlist now, yoink, close, where are they? Oh, hey, that's convenient. Flip, and then rotate. I betcha I can fit all 3 of those. Flip, rotate. Oh yeah, easy. Flip, rotate. So now I can get my 3 ports. I can squeeze them between those 2 screw holes. So on the other board, those will fit in between there, and I can mount them flush. Yes, that's what I want. Okay, so all of this is by way of saying that I am not going to mount that connector right there. I am instead, I might be able to do it up there. Oh no, because I've got those caps there. I'm going to have to do it like right there. I think we can do that. Yeah, I think I can do that. I could put it there. It'll fit there. That works nice. So those 5 volts. Oops. Nope. So I want to have lots of vias to have a good solid connection. To the power plane. Start on the bottom layer. Yoink. Okay. So I got 3 vias on each of those pads tying to the power plane on the top side. Ground's going to go on the bottom side. Okay. Let's go ahead and lay out our planes. Warning zone display is off. Well, let's turn that on. We'll do... So top layer is going to have 5 volts. Yay. And we'll do another one on the bottom layer. Bottom layer goes to ground. I'm going to do a DRC, which is going to fail spectacularly, but that's what it takes to fill in the planes. Let's take a look. Turn off the bottom. All the +5s are tied to their pads with thermals, including those. Let's look at the bottoms. Yep, those are tied. You know what? That's a solid one. Let's do this. I'm going to flip this over so that the ground tie is more solid to the plane. I'll get that out of here before you let me rotate it without getting all wonky. What? Why do you only let me do this one at a time? Okay. Run another DRC. All right, so let's look at what that just did. So there aren't holes in the ground plane here for the 5 to connect to. But there are for the ground, because they had to put holes for those other pads in there. So I moved the ground to the bottom where it had a much better connection to the ground plane over here. I feel better about this than the other one. Yeah. That's good. Now, why could I not move that closer to... Oh. Because you got wonky when rotating. No. You got off grid. I don't like off grid. All right. We'll do this again. That's fine. Okay. All right. Yeah, that's on grid now. That's good. And my top layer is nice and solid. My bottom layer has the grounds connected really cleanly, and that's all on grid. Okay. I am happy with that. So, this is a real head slapper moment. Let's take a look at this. Front copper. Let's dive into one LED. Front copper is tied to +5, which is a via down to the bottom layer where there is a capacitor +5. And the negative side of that capacitor, you see that that thermal there, that thermal connection is connecting to the capacitor on the bottom side. It is not connecting to the pad of the LED. The problem is that I also need to put a via here for the grounds. Yeah, okay. No, that's not a head slapper. I just forgot that I need to do that as well. Okay. Well, let's start over here. I got to via the grounds for the LEDs because you'll notice that they're all disconnected. Let's fix that. So let me show you something about laying out vias. Notice how my current layer is the bottom layer. When I go over here to this ground, the pad does not exist on the bottom layer, so the cursor is not snapping to the center of the pad. It's only snapping to the grid, which is not on the pad. But as soon as I switch to the top layer, the cursor will actually snap to the center of the pad. And if I want the via to be right in the center of the pad, I need to have the top layer selected to get it to snap to that. So then I click it like I'm starting to drag a... oh, I'm not... hang on. Let me actually... hey. Let me make that visible. So we're on the top... because I had escaped too many times. Okay. So it snapped to the pad in the center. You know, and I'm like drawing a normal trace sticking out of there. But if I do plus, which will swap layers, switch to the bottom layer, it also drops a via there. No, I want it to stay in one place. So I click on it. I'm now trying to draw a trace on the top layer. I plus to place a via, and I double click, and that drops the via there. But I'm now on the bottom layer, and it won't snap to the center of the next pad. So I do plus again, and now I'm back on the top layer, and it will snap. So I don't know if you can hear my keyboard, all the keyboard activity I'm doing, but that's exactly what I'm doing. So I'm on the top layer, I start, I via, I end, I swap again, get to the center, start, via, end, swap again, so on and so forth. Okay. Oop, nope. Damn it. Knock it off. Where'd I leave off? I'm over here. Okay, I think that's all. Let's find out. Yep, that looks good. All right, so let's look at... Oh, missed. Wait, what? Run a new DRC. That'll clean out the planes. Oh, yeah, no, that is going to be funky. Okay. So, you will note that the +5 and the grounds no longer have rat's nest coming out of them. There's a rat's nest that looks like it goes to a ground here, but really that is the data out of that LED. So that rat's nest goes to the top layer, not to the bottom layer. The ground you see there is the bottom layer. So that solves all of those rat's nests, and those are not keepouts. Damn it. I want those to be keepouts. Oh. Okay, so... Oh, seriously? Keep out areas can only be rectangular? Okay. Is there a keep out? Copper, silk, mask, drawings, comments, eco, edge, margins, courtyard. Courtyard might do it. Let's try that. Does courtyard do what I think it does? Nope. Nope, that didn't do a damn thing. Okay. Okay. Oh well. You know what then? Oh, so the problem is that my ground plane on the bottom is going up against the hole and the power plane on the top. And if by screwing down a screw, you scrape through any of the solder mask and the screw ends up touching the top plane, that's going to short your power and ground. So what I'm going to need to do, damn it, I was hoping that this was going to do a keep out. We are going to do a pad, a hole that has pads in it, and I'm going to tie that pad to ground. And by tying it to ground, it will do a keep out for the power on the top. And I don't understand the difference between DIN, ISO, and ISO. Pad, no, I don't need VS. We'll just do that one, M3 pad. I think they're all the same. Okay. Make those go away. No, okay. Hard to do. I just noticed that that is not centered on the corner. The others are not centered on the corner as well. All right, that's fine. Okay. Okay, run a new DRC, and that should keep out on all of the top layers. Yep, that's what I wanted to see. Oh, it's keeping out on the bottom layers too. Can I net name? Gnd. There we go. All right. Edit. Edit. Now that should get tied to the bottom plane. It did, yep, thermally. Because that is a quality of the plane, not of the pad. Ground. Net pad clearance. Oh, okay. Thermal pad width. Thermal relief gap from parent foot. Ah. Solid. I think that's what I want. Yoink. That's what I wanted. Okay. So I'm going to have to go edit all of these as well. Edit local solid. Okay. Edit. There might be a way to do this in bulk. Hey, where am I? Edit there. Solid. There we go. Okay. That's looking pretty good for a display board, don't you think? The only marring on the top are those 6 vias, which honestly, the way Osh Park makes them, they tend to get covered anyway. I'm kind of liking that display board. So, the next thing to do is to make a controller board. Edge cuts. We'll do... Actually, okay, so what's the height on that? So 5.05, 3.2... It's going to be 1.8, 1.85. So from here, I want to go down. So what is that? 5.1. So 6.95? .95. Not that one. Not that one. That one. Okay. So there's one outside and then one more. One outside and one more. Okay, so that's the right there. Let's go make sure I did this right on the other section, the other direction. Hey. I'm just going to Control Z this. Yep, looks right. Okay. So I got to make everything fit into this control board. Really? Okay. Apparently I can't copy. Oh, knock it off. Apparently I can't copy those. Holes mounting. Let's do our planes. Oh, wait, hold on. Edit. Oh, no. Edit. Make that a gund. And let's make it a solid. I really wish I could copy those. That would be nice. Gund. Solid. And edit. Gund. Oh. Am I on repeat? Have we already heard this? Nope. We're good. Okay, so another... Oops. Let's do that again. Background. You know, it dawns on me, I'm not sure how well this is going to work when trying to upload this to Osh Park if I try and put both boards on the same file. Oh, blast. Well, we'll see. Front +5, go. And DRC, fill those in for me. What do they look like? Why is there no copper layer on top? Volt copper. Why is that not filling? Will it not fill if there are no components on there? One, two, three. 1, 2, 3. Yeah, so that's centered. Okay. Okay. I don't know where that's going to go. Because that's really the only edge that's going to be visible. I guess I can make that inside the case. That's fine. So I've got some +5s on the top layer now. There it goes. All right, so apparently I just needed to have a component to tie it to before it would do that. Interesting. Okay. Okay. Those are my caps for that. How tall are vertical USB connectors? And are they taller than the headers that get sandwiched together? They probably are, so I'm probably going to need those USB to be on the bottom side of the board. Yep, I think so. Flip those, flip those, flip. There we go. silk. Oh, they were flipped. Ha ha ha. There we go. Front silk. Oops. Front silk. Bottom silk. Yep, okay. They were flipped. Okay. Which means I want these on the top side. Okay, rotating those in place was not a good idea. Because I have this thing about being on grid. It's kind of an OCD compulsion of mine. What does that look like? Okay. So that's awfully good. I gotta via those down, don't I? Oh, I gotta do the via dance. Oop. This board may need to be bigger just because I can't fit all these modules on there. Oh, that one I know needs to be there. Let me make sure it's oriented right. +5 is at the top. +5 is at the top. All right. So what's the center line and how far off the edge of the board is it? The center line is at X 5.05, and the top line is right at the edge of the board. 5.025, so close. 5, and right there. Okay. Joel says that USB-A are approximately 550 mils tall. And if I remember correctly, a male and female header stack is about that, if not a little bit right around there. Close enough that I don't want to try and squish these USB connectors between a sandwich of boards. So I am definitely going to keep these on the bottom side of the board, away from the display. Thank you, Joel. Which means that one I can probably sandwich in there. So I want that one on the top side. This module, however, is definitely going to need to be on the bottom. The power module. Make my planes go away. Actually, I probably do want that up there closer. If I were smart, I'd have a diode protection and some a fuse in there. Because I am going to be pulling some relatively serious power. Why? Ground, why? Oh! Those are surface mount. Oh, okay. Because I need to via that in. So I was looking at this ground, trying to figure out why it had some rat's nests coming off of it, because it was tied to the ground plane. I'm like, it should be connected to ground. What the heck's going on? It's not. It is tying that pad into the ground plane, which does not have a via on it, and it's tying this board to that board because this is apparently the closest ground point to that pad there. So, alrighty. Oh, so that's on the red side, so we'll do that. And we will, let's see here. Yeah, I've got to tie that through to ground. All right. Vias count as thermals, right? Yeah, they should be. Okay, so those are now tied. The +5 is also tied, but that's connecting to that. Yeah, okay. Nope, we're good. I am going to have to make this module bigger. I just don't have enough space for all this. Actually, I probably could do it if I did it like that. Get it close to the edge like that. What do you think? So that's going to be the bottom. God, I almost want to move those connectors to the bottom because I don't need elevation for those. Thinking about moving that to the bottom edge of the board instead of the top, even though it gets it farther away from that, but I think I'm all right with that. We can find ways of making that work. And then that allows me to take that and do that with it and have it stick out the top. Or it wouldn't stick out the top, but it would be at least flush with the top. It'd be pointing out the top so that the antenna would be closer to the outside surface of the clock. Yeah. Well, the other option is to do it like that. What do you guys think? Any opinions on this? Where should the micro go? I would have to kind of move it there, and that would have to get squished up some. Like that. Hey, redraw. Okay, fine. Oh, that's why. Still no place to put the serial module. I think I am okay with this going up here. I think I'll be all right with that. Going to be relatively shielded. Oh, I hate this track. I don't know. John, if you're listening, can you tell me why Lightning Hold is on this? Because it sounds like cheesy, like 80s FM synthesis, kind of King's Quest music. I'm assuming there's a game inside Hong Kong that I haven't actually played Hong Kong yet. I'm still on Dragonfall. And so I'm assuming that this music is from like an in-game game, and it's intended to be cheesy because I have a hard time listening to this one. So I'm just going to fast forward because I'm a jerk like that. Anyway, again, if you weren't with us at the beginning, the music we're listening to is the Shadowrun Hong Kong soundtrack by John Everest. I'm going to put a link in the show notes. Highly, highly, highly recommended. I like all of John's stuff that he's done for Shadowrun. Just really, just wonderful, beautiful music. If you haven't heard it, definitely go check it out. It's really good stuff. Very good, kind of down-tempo, good work music. It's kind of how I think of it. Okay. I need... What do I need? Okay, now I can fit it all on the screen better. All right, I'm going to move this down to the bottom edge, which means I'm also going to rotate it. Dang it. Okay. Boink. Do I have it all? I do. Yeah, that'll go there, but rotate, 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 rotate. Which means all of that is going to get moved over here. Actually, no. Just going to drop it in place right there. I think that'll be okay. DRC, what do you tell me? Back copper, ground goes... Forget, I can't point with my fingers. You guys can't see that. Ground goes up to the rest of the plane nicely. And +5 is tied in. Because that's a bottom fed one. Okay. If I remember correctly, the center line is at like 5.5. 5.05, there it is. Yeah, 505, and then it's at the edge of the board. And I have 5 volts on the outside edge. .505 right there. Okay. DRC. Yeah, this one wasn't quite as convenient as the other one. Ground is still a nice solid plane, but the +5, yeah, it's good enough. That's plenty. That'll get there, especially since the output is right there, so it doesn't have far to go. Okay. Okay, so we're going to move this up here now. Bring it back a touch just in case the antenna is in case the board's a little longer than I anticipate. And this one goes there. I'm going to go ahead and let that hang off the edge of the board. those as a resistor. I want that on the bottom. Shadowrun elevator music. Rat-row. It dawns on me. Oh, rats. Oh, I've got a resistor in there somewhere. Oh, crap. You know what? DRC is going to find that because... No, wait, what? There should be... There's a resistor in here somewhere. Where is it? That's reset. Something is tied to reset. Ah, that's it. You, come over here. So I will take another capacitor. Yoink. So that was our extra component that I didn't know where it came from. Yep, okay. I'll be right back. I'm going to go grab a couple of chunks of hardware and do some measurements. I'll be right back. Okay. Where'd my music go? Is it done? Oh, hey, look, it's done. All right, well, let's go back to Dragonfall. There are more tracks than this to the Dragonfall soundtrack. Chronicles Returns. I've got more tracks than this. I don't know why. Okay, well, anyway, here's Dragonfall. Also by John Everest, soundtrack to Shadowrun Dragonfall. You may know I'm on a Shadowrun soundtrack kick today. That's fine. Woohoo! Hardware chunkies. Chunksies? What are hardware chunksies? Just what I'm doing, or I'm confused, Joel. What do you mean by hardware chunksies? Or did I say something about hardware chunksies and I didn't? Anyway, whatever. Okay, so... because I'm an American, I think in inches. I'm going to angle that so you can read it. Okay, zeroed out. How tall is this? 0.550, 553 or so. And that goes to the top of the potentiometer, which looks like the tallest component. Sticks up a little bit higher than the capacitors. call it with a little bit of space for leeway, call it 0.6 inches. And then oh, but these are not the surface mount ones. Oh, shoot. I don't know how thick the surface mount ones are going to be. Oh, I probably didn't want to do that whole thing either. Yeah. Yeah, that's my 0.6 inches. So if I were to do that, headers are about, oh, that's unfortunate. So 0.443 or 429, 430, somewhere around there, 430-ish mils. So that stack of male and female headers is shorter than that, which means that this has to go on the back side of the board, not the front side. And that all assumed that I'd be able to surface mount it, which I can't do because that resistor has through-hole components. So it's going to stick out a little bit. So I'm definitely going to have to mount that on the outside board. Oh yeah, I was going to go measure a 2812. I'll be right back. Not a 2812, ESP. All right, so here is one of the super common ESP8266. It's an ESP01 module. This one does not have the headers dropped into my keyboard. This one does not have the headers already soldered in. So in the bottom side of that is flat. There's nothing sticking out of it. So in theory, I could surface mount this. I've done it before where you just lay the two boards right on top of each other and then solder the pads together. It's not super convenient, but it can be done. But even if we don't do that, even if we put these headers in there, which make it easier, a heck of a lot easier to solder, let's see how thick that is. From the board, including the headers, is call it 0.16. That does not include any of the components. And so plus another 0.08, so about 0.24, maybe a quarter of an inch total. So 0.24, 240,000. So I actually have like 200 mils clearance if I were to put this on the inside. The question is, what does that get us? Does that buy us anything? I'm not convinced it does. So just having it on the outside with the USBs and the power, that will make it... I'll actually get it on the outside. It means I don't have a couple of ground planes. Yeah, never mind. I'm keeping it on the outside. And actually, while we're here, let's go ahead and flip this sucker. There we go. This one's going to stay on the front side, which is now the outside or the inside, because I don't want it to get in the way of that, and I can't push all that stuff over. There are tall headers, but if you want to use from your stock, yeah, no, that's true. There are tall headers. I'm actually going to have to buy headers anyway because these are all surface mounts, and none of the ones I have are surface mount. So, yeah, it's going to be a bit of a hack anyway. I think I'd rather have this stuff... Oh, hey, I got to flip those so they're accessible from the outside. I think I'd rather have everything exposed on the outside anyway. Because remember, this is going to be the back of the clock. Nothing's going to be seeing this stuff. Yeah. Okay. You run the DRC every once in a while to make sure your planes are doing the right thing. So we got a bunch of people watching right now, but not many of you are talking in the chat room. Do me a favor and say hi in the chat room so I know who's watching right now. Hi, everybody. I'm Smitty. Okay, so after putting all those planes in place, I do have a lot of traces to run over there, but yeah, this isn't so bad. So I am kind of curious how Osh Park is going to try and price that if I try to upload that. So let's see what happens. There we go. See if we can do this without actually sharing anything that I'm not supposed to share. Actually, no. Where am I going? I don't want my user profile. I want that. Get started now. Yeah, I know. Silent bunch, says Joel. That's okay. I'm not going to shame anyone for not wanting to chat. That's fine. When I first started these streams, the reason I started it on Hangouts, the whole idea was to be able to do kind of an interactive back and forth between folks watching and me, and that worked pretty well. We had a guy, Tanker 401st, Tanker 401st, would show up a lot, and he and I would chat, and he'd ask questions, and I'd answer them, and he'd point out mistakes in what I was doing, and it was fun. It was good fun. Yeah, see, that's what I was afraid of. Damn it. Detected unsupported drill slots. Yeah, because I'm doing two different boards. Grrr. KiCad processing includes redrawing your fill zones. Please verify any copper fills. Oh, really? Let's give me larger versions of these. Yeah, that's what I was afraid of. So it's going to try and fab both of them, which means I'm going to end up paying for this space over here even if I don't use it, which means I am going to have to split these out into different files. Phooey. Okay. Well, how long have I been going? I've been going for almost 2 hours now. I think I'm going to go ahead and take this opportunity to take a break here. Let me stop the music. Okay, so I've made some good progress. I think I'm going to call it a night, call it a day, an afternoon. Looks outside, still sunny, it's afternoon. It's 1 o'clock in the Pacific Zone. It's time for me to get some food. That would explain why I'm kind of rumbly. All right, so what did we do today? We got the board laid out. I still haven't put down any traces, but I figured out now what the board physical layout is going to look like. And in fact, I'm going to recreate this. Oops, those go over here somewhere. I'm going to recreate this on two separate files. There's going to be some copy and paste involved here. At least I hope that KiCad will let me copy and paste across multiple files. Or if I can do multiple boards out of a single schematic. I'm going to need to figure out how to do that for my headphones as well. Dadgummit. Okay, anyway. Boards. I've got my clock board laid out. I've got my controller board. I think that's a reasonably good layout. I'm a little bit worried about that being on the wrong side or the opposite side of everything else. But you know, everything's looking pretty good. I like the way this is laid out. I've got my USB ports exposed on the outside. I got my program and reset buttons here. The microcontroller, the Wi-Fi antenna is, you know, on the outside edge. It's not perfectly exposed, but it's there. The connectors between the two boards are there. I've got my 3 amp power supply module there that'll power both the clock and the USB ports. I've got the serial header for programming it with an exposed USB cable over here and with an exposed 12-volt power input here. That's just going to be kind of sticking out, and then we're just going to have the cables go into the box and connect into those. So there are probably better ways of doing that, but I think that'll be good for now. I am pretty happy with how that's going to work. This is going to sandwich on the back of that when all is said and done. And then I'll have to figure out either a 3D printed case or a laser cut case, like in a sandwich of acrylic and maybe some wood or something. I don't know. But yeah, I think this is going to turn out pretty nice. Yeah. So I've been Smitty Halibut on Twitter and YouTube and various other places. Give me a holler and let me know what you think of the project, or if you had any questions, or tell me what you're working on. That's really actually what I enjoy. I like hearing from my viewers and getting inspired by what it is that you guys are doing, or if something that I've done has inspired you. Tell me about that. I want to know about it. I want this channel to be kind of interactive, and you guys ask me questions and I ask you questions, and we chat and all kinds of fun things. If you want to chat with me, probably the best place is on Twitter. I am Smitty Halibut there, SmittyHalibut. I'm pretty darn active on Twitter, and but I'll also see YouTube comments if you post them down below. Also, subscribing on YouTube is a thing, so give me a subscribe, and don't miss any of my episodes. I do a lot of kind of the circuit layout like this. I've also have random things that I do every once in a while. Like a couple weeks ago, I helped my friend Dave put an antenna up in his trees at his place up in Washington, and that was a lot of fun. Yeah, I think that's about it. Thank you very much, everyone, for watching, and I will catch you next time. Be good humans, and yeah, have a good time.